Getting close to the end here, folks. I'm going to talk a little bit about section 6.5. I'm kind of picking and choosing here at the end. Talk about a little bit about determinants. Determinants are important. Now, we kind of glossed over how to find inverses of matrices, and it's kind of good because nobody actually wants to do that in real life, but honestly, finding inverses of matrices takes forever. So I'm actually going to write that down. Finding inverses of matrices takes forever. Now, again, you're doing little 2x2 matrices, 3x3 matrices, and those are excruciatingly fast to do, especially on a calculator. But I'm talking about, like I've mentioned, crew scheduling problems, distance, shortest path problems. These are million by million, 10,000 by 10,000 matrices. And when you're trying to solve problems with matrices that big in it, finding the inverse takes absolutely forever. So one of the first things you want to know is, well, can I actually find an inverse for that matrix? So I'm going to say this. I'm going to say determinants are like a health check. For a matrix. Okay? It's easy to find determinants. It's hard to find matrices. Trying to find inverses. It's easy to find determinants, but hard to find inverses. So, what we do is we'll actually find, a lot of times for large problems, we'll find the determinant first. If the determinant of A, for example, that's the way that we say it. If the determinant of A, that's actually not how you say it, that's how I say it in MATLAB. I'll just write it out. If the determinant of A is 0, then there is no inverse of A. If the determinant of A is 0, it has no inverse. If it's non-zero, then we do have an inverse. And when we do have an inverse, that makes us happy. Yay, we do have an inverse. All right, so I tried to sneak in I tried to sneak in some symbols on you, and they were not appropriate for this class. So this means determinant of A. Determinant of A is the big, long, extra long lines on both sides of the A. On your calculator, I do think they actually use the word DET to also be the determinant of A. So if you want to find the determinant using your calculator, you can do that. Determinant's not, so if the determinant is non-zero, it has an inverse, the function has an inverse. The determinant is 0, it doesn't have an inverse. And again, this becomes important because determinants are so easy to get. So determinants are easy to find. And when I say easy, I mean it. For a 2x2 are super easy. And I almost never use the word easy in a math class. But by the time you get this far along in college algebra, they are super easy. So if I wanted to find the determinant of this, what I actually do is I take these times each other minus these times each other. All right, so it's actually, I'm just trying to figure out a good way to write this. It's this minus that. Cross, and subtract them. So I've got 1 times negative 1 times negative 5 minus 3 times 2. So 5, I'll do that in black. So I've got 5 minus 6 is negative 1. The determinant is negative 1. So this matrix has an inverse. So please don't waste time on a test plugging a 2x2 matrix into your calculator to find the inverse, because they're really not that bad. So let's just do a bunch. So we've got, say I've got this one, and I want to find the determinant of A. So I say 3, 2, 6, 7. Well, that's going to be this. 3 times 7 minus that. 6 times 2. So 21 minus 12, or what is that? Come on, I can do it. 9? 9. The determinant is 9. So this system has an inverse, not system. This matrix has an inverse. See, aren't these fun? It's just like, it looks really complicated, but it's not that bad. What if A is 3, 2, negative 6, negative 4? And I want to find the determinant of A. 3, 2, negative 6, negative 4. I'm going to multiply this one. 3 times negative 4 minus this one, which is 2 times negative 6. And that's going to give me 12, negative 12, minus negative 12. Minus 12 plus 12 is 0. Oh, so look. A inverse does not exist. So based on our discussions from solving problems, what does it mean if A inverse does not exist? That means that if this was in a problem, like a linear equation, there would be no solution to this problem. So you can see where if you're solving million by million matrices and matrix problems, it's really helpful to be able to just find the determinant really, really quick and move on from there, because you could just determine whether it had a determinant or not and move on with life. And if it doesn't, you know that you're done for the day. You don't even have to solve anything. All right. Now, 2x2s, reasonably straightforward. 3x3s are actually not bad either, but your tolerance for all mathematics at this point is probably close to nothing. 3x3s will do, or bigger, I should say. On the calculator. Again, they're not bad, and they're infinitely easier than finding inverses. It's just one of those things that people don't like to do by hand for some reason. We've established that I love doing all math by hand the hardest way possible because it's fun. That's what I do instead of, I was going to say instead of having friends, but I thought that was going to sound really bad. I have friends and math friends. Alright, so if I wanted to find, I meant to say this. If this is my A, I was too busy thinking about my fabulous math friends. And if I want to find the determinant, oops, I still have that going on. I can go into my matrices and put one in, 3x3, and it's going to be a 1, 2, negative 1, 1, 4, negative 2, 2, 3, 1. Alright. So if I wanted to find my determinant, this is where you find it. I'll put my key presses on so you can see it. I'm going to go to Matrix, over to the Math. So I tabbed over to the Math tab. See DET, that stands for determinant. Determinant of A. So the determinant of A is 5. Okay, so we're just going to do that. The determinant of A is 5. Now where this comes into play is I could now ask you, does this system have a solution? So if I gave you a problem like this, where I said x plus 2y minus z is 3, x plus 4y minus 2z is 6, 2x plus 3y plus z is 2. Does this system have a solution? And if I'm not actually asking you to find it, I just want to know, does it have a solution? You say, well, let's find A. A is going to be 1, 2, negative 1, 1, 4, negative 2, and 2, 3, 1. So that's my A. I know at some stage I'm going to have to find A inverse B. As long as A inverse exists, I have a solution. So does A inverse exist? Well, the determinant's not equal to 0, so A inverse exists. So I can find, can spell, so I can find a solution. There is a solution to this problem because the determinant is non-zero, so the inverse must exist, so I can find a solution, so all is well and good with the world. I want to clarify. I'm saying that I can find a solution or I can't find the solution. I didn't say no solution. Really what I mean is, like we said previously, there's no solution. There could be, so go ahead and fix this in your notes, could be infinitely many solutions. And we're not going to talk about how you can tell at this point. So just know that there's either going to be infinitely many solutions or no solutions if you have a inverse that doesn't exist. If the inverse exists, you have a solution. If it doesn't exist, you don't have a solution that you can do anything with at this stage. So that's kind of what I mean by we have no solution. So just make sure you kind of get that. I don't think they're going to make that distinction in your homework, whether it's no solution or infinitely many. It's just you don't have a beautiful, like, X is this, Y is this kind of a solution going to this problem.